Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem substring with concatenation of all words. But before we get started, if you'd like me to make more of these videos, please subscribe to the channel to let me know. When you subscribe to the channel, it lets me know that you are enjoying these videos and you'd like me to make more of them. Alright, so let's get started. This says, you are given a string S and an array of strings words. All the strings of words are of the same length. A concatenated substring in S is a substring that contains all the strings of any permutation of words concatenated. For example, if words is this, then the following, then each of these are all concatenated strings. And that's because, when you look at this, you can see that you can form that by concatenating any combination, a certain combination of these. You can only use each one of these once. So like, let's look at this one. We see the CDs at the beginning, then the EF, then the AB. Okay. But this is not a concatenated substring of the words. So when we look at this, we see the EF is at the end, but this this DB does not exist in here because we're not doing a permutation of this one right here. We can't do that. It has to be these words, and then they can be concatenated together in any combination to fill out the full string. Return the starting indices of all concatenated substrings in S. You can return the answer in any order. So let's look at the first example. First example has this string, and we can see that foo and bar, when we concatenate these two together, then they're at the beginning here, which is location 0. Then we can see that the concatenation of this here, foo and bar, is at location 9. So 0, 9 is our answer for that one. Let's take a look at the constraints. So the length of the string they give us is 10 to the 4. The words length, number of words in the array, can be up to 5,000. Each of the words inside the string could be anywhere from 1 to 30. And it says that S in words consists of lowercase English letters. So when we look at this, we see that of all of these, they at least have one in there, so we don't have to worry about doing like null checks or empty checks or anything like that. It's all guaranteed to have at least one. Okay, let's think about this conceptually then. Let's head over to the whiteboard. Okay. So essentially what we're going to be doing is we're going to be looking to see if we have all concatenated words. And if we have that, then we provide the start index of where that is. So we could look at this first one here. We know, another thing it said is that all the words inside of this words array are the same length. So we see that they all have a length 3. So we'll have our window be of size 3. And if we see that, then we keep track and we say that we've seen that. So we can keep track with like another hash map. Let's put that over here, and we'll call it seen. So we've seen bar once so far, and then what we'll do is we'll slide this over to the next word, and then now we see there's a foo, so we've seen foo so far. Okay, and that's the amounts that we need to have an answer. So that's when we would, then in our answer array, we'll go ahead and put the start index, which is 0. And then we'll move on to check more. So when we check another one, so remember we went from here to here. So now when we move on to check another one, we're starting here. Because when we do this, we're going to be like this and then that. We'll, go on and on and on, etc. So we're going to check this one. And then if that was one of the ones, then we would go check the next group of three. But since this is not one of the ones, we don't have to go to check the next group of three because since it's not one of the ones, like it's not going to work. So we can just skip to go to the next, and we see that's not one. Okay, we see this is one, so that's good. And by the way, each time we're resetting this scene. So let me start over. So we're here. All right, we found that. We said bar equals 1. Since we found that, since that is in there, then we go to the next set of 3. And since we saw that, we put that in here. And since that matches with what we need, we have the result as 0. And then now we're going to go check to see if we can find another one. So we just found one at location 0. Now we're going to go to location 1. We're going to go like 0, 1, 2, 3. We're going to increment all the way up. So now we're starting at location 1. Let me go ahead and write this up here so it makes more sense. So we were at I, and then at location 0. Now we're at location 1. And we're going to see, is this in here? It's not, so we can just go ahead and go to the next one. We don't have to check more of that. So that's not 1 either. So we're going to move this up here to go to the next set. Oh, we found one. Great. So we found one, so we're going to add that in here. We've seen it once. And then we're going to see the next set of 3 for that. That's not 1. So we are going to be moving this I up here, come back here, and this resets. We don't see one here, so this I moves up. We don't see one there, so this I moves up. Don't see one there, so this I moves up. Don't see one there, so this I moves up. Don't see one there, so this I moves up. Okay, we just saw one, so that's good. So we're gonna keep track of that. We've seen this. And then now we're gonna go to the next set of 3, which is this. And great, that's also 1. So we keep track of that. That ends up being the amounts that we need. So we record where I is at, which is 9. And then this moves up. Don't see one there. This moves up. Don't see one there. And then we just keep on going till we get to the end. I'll just do that real quick. Oh, well, now we see one, right? So, so we mark that. We've seen that. But that's not one. So this resets. And then now the loop ends because if this comes up here, we wouldn't have enough to make what we need. So let's dive back here and think about the algorithm to do something like this. So one thing is we need to figure out how we're going to make these substrings. So we can say, let's call this start. So start equals, so we have I, which is right here. And if we added to I, make this like super big real quick here. This up. If we added to that some other variable, let's see. So well, we have our other variable. We need this to, which is going to be which is going to keep track of. Let's see these words real quick here. So we keep track of where we are in the words. Let's call that J. So j will start out the words. So we would have like a j and then times the words of 0.length. I can just say 0 here because remember, they're all the same length. You could put j in there if you want to, but you don't need to because they're all the same length, guaranteed by the constraints. So if we have the start is going to be at location I, which is 0, plus j times that. J is currently 0. This is currently 0 here. So the start starts out at 0, and then our end now needs to be the start plus the words of 0.length. Because remember, in a substring for Java and also Python, we are the end is going to be exclusive. So so this is going to be 0 plus 3. So that would put that right here for the end, but it's exclusive. So for the end, so it's right here. So we have this. Okay, great. And then so that finds that 1, right? And that puts that over here if we see it. Bar equals 1. We've seen it once. And then we're going to move this j up to the next word that we're going to look for. So we would have 0 plus 1 times words.length, which is 3. So 0 plus 3 would be at the start. So that's 3. So this moves up to 3. And then the end is 3 plus 3, which is 6, and we're doing exclusive. So that's the next word. And we see that that exists in frequency words. So we'll add that. And then now we've fulfilled, look, we found them all, right? So if our j is at the end of this words array, and you know, what we have just saw is inside of this frequency words, then we have found a solution. So we'll say that like if j equals words.length minus 1, then that's when we found solution. So that's when we would add the I into results index. So I'll just say that. I'll say like indexes dot add I. Okay. All right. We got to think about our loop bounds now. So let's see. We know that the loop bounds of this orange one is going to be like this. As long as j is less than words.length. Because look at this j, we just want this to go to the words.length. And then, so we're going to have something like this. Like we're going to start, j is going to start out at 0 at the beginning. And then we'll loop as long as that's true. And then on each loop, we're going to add 1 to j. Okay. Now what about this I? So after we've gone here and then here, then what? Well, the I, we know it's going to increase by 1. Okay, so let's write that. So the I, we know we want the I to start out at 0. And then we have some condition. And then we know we want the I to increase by 1. And I'm doing plus equals 1 just because that works in both Python and Java in this conceptual thing. When I write Java code, I'll do the plus plus, and then when I write the Python code, I'll do the plus equals 1. But okay, so now what about this question? So the question, that's when we got to stop. So remember when we were over here in this scenario, and we checked that, and we said, oh, that works, and then we got our next one. We said, oh, that doesn't work. We knew to stop at this point because we knew if this I came up here, there wouldn't be enough enough in this string left to form two words, which is what we need because we see this words array. So we can write that. Let's put this back to a valid one. We can write that like this. We could say, as long as I is less than or equal to s dot length so s is our string here, s dot length minus, and then this is going to be the words dot length, so the words length of this array times the length of each one of these here. So if we have this is 18, so let me write all this out. So we have 18 minus, and then that would be the words length. There's 2 times 3 is 6, like that. So then that's going to be 12. And then, so that says as long as we're less than or equal to 12, then we're good to go. But once we are not, when it's at 13, then we need to stop. Okay, so we have what we need now for this algorithm. So let's go write the code. Okay. Alrighty, so let's make some space here. Okay, so we'll start with these, the indexes. Okay, so this is going to be the answer. This is where we're going to store the answer. Okay, next we know we need a map. This is going to keep track of the counts of the words that come inside this words array. Okay, and then we need our loop. So we said that I is going to start at 0, and we also said that I is less than or equal to string length minus, and then that was the words length, the length of the words array, times one of the words length. So that's what ended up being 6 in our example. And then we said that each time we're going to increment I by 1. And then now we had that scene map. And then we looped over our words array with j. We had j less than words.length. And then in here we calculated our start, I plus j times words of 0.length. And then our end, which was the start plus the words of 0.length. So then we could create our substring. Okay. And then we said we want to check to see if the substring was in the map. So if it wasn't in the map, then we didn't continue in this loop here. So check to see if it's not in the map first. If it's not in the map, then we'll just not continue. If it is in the map, we have to see if if we have exceeded the number of times that we're supposed to see it. If it's showing up more than what's in our words array, so we'll say get, and then we could just say get or default, so we don't have to check to see if it contains it first. So we could say subster 0 is equal to frequency map dot get subster break. Because what we're going to say is like, if what we saw is greater than what we're supposed to see, then we will just, that's a bad scenario, so we end. If what we're supposed to see is 0, this is like invalid. Every time we put something inside the scene array, we're going to have it have a frequency count of 1. So this is, you could say it like this. Anyway, you could check to see if it doesn't exist in the map. But what we're going to do is we're just going to do the getter default, and if we'll default to 0 if it's not there, and if that's the case, then that's when we break. And that's valid because actually we can't, sorry, let me step back a little bit. We can't say if it doesn't exist in scene yet because that's a valid scenario. If it doesn't exist in scene, that's a valid scenario, but if it is, let me see, let me explain it like this. Actually, I'm not explaining it very well. If we have the frequency map and it currently has like foo equals 1 and bar equals 1, and then we just have the substring right now called foo, and let's say our scene map currently has in it bar equals 1. So in this case, when we get try to get foo from scene, the default's going to be 0. So we're going to say 0 greater than or equal to, and then the foo exists in there, which is 1. And that's not true, so we're not going to enter this loop. But if this was like blah, then this would be 0, right? Because it doesn't exist in scene. And then blah didn't exist over here, so we broke first. So I guess I could just, yeah, anyway, so so that's what's happening. I could clean this up a little bit to make it a little more intuitive. Let's I'll clean it up after I submit it on this video. So next, what we'll do is go ahead and add to our scene. So let's say scene.put subster scene get or default subster 0 plus 1. And we'll say if j equals words.length minus 1, then indexes.add I. Okay, let's run that. And we'll submit it. Okay, and it passed. All right, we see that there is some like speed improvements we can do. And if we make use of the fact that these are lowercase English letters, and instead of hash maps we use arrays, we could speed it up. This code's more intuitive though, and it has the same big O, so that's why I'm going with this. All right, let's let me make this a little more intuitive. So we said that if it so let's see, let's move this up here instead. And then now that already exists inside the scene map, so then let me comment this out. I'm going to make this line a little more intuitive. So now that that already exists in the scene map, we can access it. We don't have to do the getter default. We can just say get substring. And if that ends up being since we're down here at this line now, we know it exists in the frequency map too, because otherwise we would have broke right here. We could say this, we could say get subster. If that ends up being the case, then we can break. Okay, so we could reduce this a little bit more with this right here. Could reduce that. Let's run this first though. Okay, so that passed. All right, now we could, well, why don't we just do this? I mean, we could say this, two ways we could do this, get or default, and then just have it -1 or 0, and that would work. Whichever one seems more intuitive to you that way, or we'll just add this to the beginning here. This also works. This is probably a little bit more intuitive here. Okay, let's run that. Okay, great. A little bit slower though, because we could have broke before doing those checks. It doesn't change the big O, but it just changed the real world time running scenario a little bit, because we could have just like broke before we updated the map and then did this check. So, all right, so let's hop over to the Python. Let's write this in Python. Got a lot here, so I'm just going to copy this real quick and throw this on my other screen here, and then we'll just go write this in Python real quick. Okay, so actually I'm going to pause the video so that the length of this video isn't super long, and then I'll show the code. And here's the Python code. And you know, I added one right here since we don't do a less than equal to on the range of this. I need it to also work with less than equal to, so I added one so that it would get to the equal to part. Okay, everything else is the same. Okay, so if you liked this video, please subscribe to the channel to let me know that you would like me to make more of these videos. And have a good day. Thank you. Bye.